Complete the following table by placing a tick in any box where the given statement is true. And here we're given three different shapes. This is basically testing your understanding of quadrilaterals. Quadrilaterals are any shapes with 4 angles and 4 sides. Here we've got 3 specific ones. So we've got a kite which looks something like this. Okay, that side and that side are equal, and that side and that side are equal. Those two angles are equal. A rhombus is something that I also call a pushed over square. In a rhombus, all 4 sides are of equal length, and that side are parallel, and that side's parallel to that one. A parallelogram, similar to the rhombus, is a pushed over rectangle, something like this. So that side's parallel to that one and of equal length, and that side's parallel to that one and of equal length. So in the question we're asked to tick where the diagonals are not equal in length. Well, here there's a diagonal here and a diagonal there. Those aren't equal in length. In a rhombus, that line is going to be shorter than that one, so they're not of equal length. In this one, it's not as clear as in the rhombus, but that line's going to be longer than that one, so they're not of equal length. There's only one line of symmetry. By line of symmetry we mean being able to place a mirror somewhere, and then you get the perfect reflection of that shape in the mirror to create the whole shape. So if we place a mirror there, we're not going to get that, we're going to get a diamond shape. If we, however, place a mirror there, then you're going to get a perfect reflection of that. So you have only one line of symmetry in a kite shape, which is down there. In a rhombus, if you place a mirror there and a mirror there, then you'll get a perfect reflection, but you've got 2 lines of symmetry, so you don't put a tick there. In a parallelogram, interestingly, if you put a mirror there, at first you might think that that shape is a perfect reflection of that. Well, it would be if you could take a reflection and flip it. If you flip that shape, then it would be a perfect reflection, but in fact you don't get any lines of symmetry in a parallelogram, whether you put a mirror there, 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 or there. So you leave that unticked. The diagonals bisect each other. Well, that line will bisect that line, but that line won't bisect that one. By bisect I mean cut exactly in half, cut the line exactly in half. Here the diagonals may be of an equal length, but they will bisect each other, so that line will cut that one in half and vice versa, so we can put a tick there. And the same goes for the parallelogram, so put a tick there. On to the second part of the question. It says write down the name of the 3-dimensional solid that has only 4 faces, all of which are triangular. Now the answer is going to be a pyramid, but a specific type of pyramid. The ones you see in Egypt are basically square-based pyramids, so there's something like this. So, but you've got 5 sides to that. So what we've got here is basically a triangular base. We've got that sort of shape. So you've got 4 faces to this shape, and this is called a triangular based pyramid. The name of the three-dimensional solid that has only 5 faces, 2 of which are triangular and 3 of which are rectangular. Well, to me, that's something called a prism, which looks like that. And it might be enough to say prism, but if you want to be very specific, you can say a triangular prism.